4.1.1, we have to evaluate the integral of 7x minus 2x cubed, all multiplied by e to the power x to the power 4 minus 7x squared dx. We choose to write our integral as e to the power x to the power 4 minus 7x squared multiplied by 7x minus 2x cubed dx. In this case, we have to let that equal u, so we have to let u, so we let u equal to the power 4 minus 7x squared. We differentiate u with respect to x. Differentiating x to the power 4, we get 4x cubed. Differentiating negative 7x squared, we get 14x du. So we multiply both sides by dx, and du will be equals to 4x cubed minus 14x dx, and we have 7x minus 2x cubed there. So let's try to mirror this based on that. So from here, we take negative 2 as our common factor, and we'll be left with negative 2x cubed minus plus, because we are taking negative 2 as our common factor, plus 7x dx. We divide both sides by negative 2, so du over negative 2 will be equals to negative 2x cubed plus 7x dx. But let's choose to write the 7x first, like they did there, minus 2x cubed dx. So now that we have minus 2x cubed multiplied by dx, so we managed to mirror du over negative 2 with that. So in the place of 7x minus 2x cubed multiplied by dx, we'll substitute du divided by negative 2, and we already said that x to the power 4 minus 7x squared is equals to u. So let's write this 1 over negative 2 out of the integral because it's a constant. So inside the integral, we will be left with e to the power u du. So that negative 1 over 2 multiplied by the integral of e to the power u is e to the power u plus c. Our integral being in the form of x and not u, we substitute x to the power 4 minus 7x squared in the place of u. And this will be the answer for question 4.1.1. 4.1.2, we have to evaluate the integral of 6 divided by 7 plus x squared dx. We can choose to write the 6 out of the integral. To evaluate this integral, we have to use our formula sheet. On our formula sheet, we have f of x as 1 over a squared plus x squared, and the integral of f of x with respect to x is 1 over a arctan of x over a plus c. We can express this integral as 1 over, so we know that 7 is equals to the square root of 7 squared, so we'll express that 7 as the square root of 7 squared plus x squared dx. So when we integrate that, so our a, in this case our a will be equals to the square root of 7. So our integral is going to be 1 over a, our a, which is equals to the square root of 7 arctan of x over the square root of a, which is 7, plus c. We can choose to rationalize that 1 over the square root of 7. So we know that 1 over the square root of 7, we can multiply it by 1. The square root of 7 multiplied by the square root of 7. So 1 multiplied by the square root of 7 is equals to the square root of 7. The square root of 7 multiplied by the square root of 7 is equals to 7. So this can be rewritten as the square root of 7 over 7 arctan of x over the square root of 7 over 7 plus c. And this will be our answer for 4.1.2. Question 4.1.3, we have to evaluate the integral of 3x cubed plus 4x squared minus 6 all divided by x minus 2 dx. We use long division to evaluate this integral, where 3x cubed plus 4x squared minus 6 has to be long divided by x minus 2. 3x cubed divided by x is equals to 3x squared. 3x squared multiplied by x is equals to 3x cubed. 3x squared multiplied by negative 2 is equals to negative 6x squared. We minus 3x cubed minus 3x cubed is equals to 0. 4x squared minus 6x squared is equals to 10x squared. Unfortunately, we didn't write this in our standard form, so we're supposed to have 0x minus 6. Since we don't have anything which links to x, so we'll have x, 0 as the coefficient of x, and we take down that 0x. So we'll have 10x squared divided by x is equals to 10x, and 10x multiplied by 10x is equals to 10x squared. 10x multiplied by negative 2 is equals to negative 20x. 10x squared minus 10x squared is equals to 0. 0 minus 20x is equals to 20x. We take down the negative 6. 20x divided by x is equals to 20. 20 multiplied by x is equals to 20x. And 20 multiplied by negative 2 is equals to negative 40. 20 minus 20 is equals to 0. Negative 6 minus 40 is equals to 34. Since we don't have any x pairing with this 34, so we just write this as 34 divided by our denominator, which is x minus 2. So our integral 3x squared plus 10x plus 20 plus 34 divided by x minus 2 dx. And again, you can substitute any number on this expression. If you substitute 8 in this expression and substitute 8 again in that expression, you should be able to get the same answer, to prove that you didn't make any mistake with these steps. So we integrate 3x squared, we get 3x cubed divided by 3. Integrating 10x, we get 10x squared divided by 2. Integrating 20, we get 20x. And we integrate, so let's integrate 1 over x minus 2, we get ln of x minus 2. So that can be expressed as so when we integrate 1 over x minus 2, we get ln of x minus 2 multiplied by that 34 plus c. That 3 will cancel out with that 3, so we'll have x cubed plus 10 divided by 2 is equal to 5, x squared plus 20x plus 34 multiplied by ln of x minus 2 plus c, and we have this as the answer for 4.1.3. Question 4.1.4, we have to evaluate the integral of sine 4x multiplied by cos 7x dx, and we use our formula sheet to evaluate this integral. On our formula sheet we have sine A multiplied by cos B, and this is equals to 1 over 2 multiplied by sine A plus B plus sine of A minus B. So our A in this case will be equals to 4x, and B will be equals to, our A will be equals to 4x and B will be equals to 7x. So this integral will be equals to 1 over 2 in brackets sine of 4x plus 7x plus sine of 4x minus 7x dx. We can write that 1 over 2. Okay, let's retain it for now. Sine 4x plus 7x is equals to 11x. (4x) minus 7x is equals to negative 3x dx. Let's move that 1 over 2 out of the integral. Okay, that's not necessary. So we integrate sine for the integral of sine 11x is equals to minus cos 11x, and because of the chain rule we have to divide by 11, and the integral of sine of minus 3x is equals to negative cos of minus 3x divided by negative 3 plus c. That negative multiplied by that negative, or that negative divided by that negative, will be positive 1 over 3 cos of minus 3x plus c. We can leave it here, but we also know that cos of minus theta is equals to cos theta. So in our case, cos of minus 3x is equals to cos 3x for all values of x. So we can express that as the 1 over, so we can also distribute the 1 over 2 inside the parenthesis. So that 1 over 2 multiplied by that 1 over 11 will have 1 over 22 minus 1 over 22 multiplied by cos of 11x plus that 1 over 2 multiplied by that 1 over 3 will have 1 over 6 multiply. So when we express that cos of minus 3x, let's express it that way, cos 3x plus c. So this will be our answer for question 4.1.4. Question 4.1.5, we have to evaluate the integral of the inverse of sine x dx or arcsine of x dx. There is no specific method that we can use to evaluate this integral, so we resort to integration by parts. We'll have 1 multiplied by arcsine of x dx. Since we will be using integration by parts, we'll have the integral of u dv is equals to u multiplied by v minus the integral of v du we have to determine the value of what the function u and the function dv. We know that we have to differentiate this function and also integrate that dv so that we can get v. So we are already looking for the integral of arcsine of x. So we cannot set dv as arcsine of x because we have to integrate it. And if we were to set 1 as equals to u, when we differentiate that 1, we will get 0 and it will nullify our integral. So we have to set 1 as dv and the arcsine of x as our u. When we differentiate u with respect to x, we get 1 over the square root of 1 minus x squared, and this can be found on our formula sheet. We integrate dv, so when we integrate 1 with respect to x, we get x. So 1 multiplied by arcsine of x dx will be equals to u multiplied by v. So u multiplied by v, u is equals to arcsine of x, and v is equals to x minus the integral of v multiplied by du. Our v is equals to x multiplied by du, which is equals to 1 over the square root of 1 minus x squared dx. To evaluate this integral, we have to let u equal 1 minus x squared. We differentiate u with respect to x. When we differentiate 1, we get 0. When we differentiate negative x squared, we get negative 2x. We multiply both sides. We multiply both sides by dx, and du will be equals to negative 2x dx. We have x dx without this negative 2, so let's try to mirror what we have here based on that. So we divide both sides by negative 2. So du over negative 2 will be equals to x dx. So we already figured out that part, so we are left with that part. So let's carry out that part without this negative. So x dx, that x dx will be substituted with du over negative 2, and 1 minus x squared will be substituted with u, and this integral. So that negative 1 over 2, we can write it out of the integral, and we'll be left with du over the square root of u. We can express that integral as 1 over u to the power 1 over 2 du, which can also be expressed as u to the power minus 1 over 2 du. So now we integrate u to the power negative 1 over 2, we get u to the power 1 over 2 plus c, and in the place of u, let's substitute back. 1 minus x squared raised to the exponent 1 over 2. So in that place, so now that we have determined the integral of x over 1 over the square root of 1 minus x squared dx as negative 1 over 2, we can go ahead and substitute it there. So this negative multiplied by that negative will be positive, and we'll be left with 1 over 2 multiplied by 1 minus x squared multiply raised to the exponent 1 over 2, which we can rewrite as the square root of 1 minus x squared. And this will be the answer for question 4.1.5. To evaluate the integral of x minus 1 divided by x squared plus x dx, and since the denominator has a higher power compared with the numerator, we have to use partial fractions. So we take x as our common factor in the denominator. This will be equals to a over x plus b over x plus 1. We multiply both sides by that denominator x multiplied by x plus 1. That x plus 1 will cancel out with that x plus 1, and that x will cancel out with that x, and we'll be left with x minus 1 on the left hand side, and we distribute the x multiplied by x plus 1 inside our parentheses. That x plus 1 will cancel out with that x plus 1, and this x will cancel out with that x. And from here, we have to let x equal any two numbers. But the easiest number that we can work with are x is equals to -1, because we substitute x is equals to -1. -1 plus 1 is equals to 0, and 0 multiplied by a will be 0, giving us an opportunity to determine the value of b. -1 minus 1 is equals to -2, and like we said, -1 plus 1 will be 0, and 0 multiplied by a will be 0. So we substitute -1. -1 multiplied by b is equals to -b. So we divide both sides by -1, or we multiply both sides by -1, and b will be equals to 2. The other number that you can work with is 0, because if we substitute 0 here, 0 multiplied by b will be 0, and that will give us an opportunity to determine the value of a. You can substitute any number, so you can choose any number for x, but the easiest number that you can work with are -1 and 0. So 0 minus 1 will be equals to -1. 0 plus 1 is equals to 1. 0 multiplied by b is equals to 0. So a will be equals to -1. So our integral a, we said, is equals to -1 over x plus b is equals to 2 over x plus 1 dx. When we integrate 1 over x, we get ln x. We integrate 1 over x plus 1, we get ln of x plus 1 plus c, and this will be the answer for question 4.2.